In this video lesson, I am going to discuss to you the Quarter 1 Module 4 or the Illustrating Geometric Sequence. Let us first define some important words that you are going to encounter throughout the discussion. First is the geometric sequence. It is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant. Example, we have here the first term as 5 and we have a constant number 2. So we are going to multiply 5 by 2 to get the next term. So 5 times 2, that is equal to 10. To get the next term, we multiply again 10 by the constant number 2, so we get 20. Multiply again this by 2, we got 40, and so on and so forth. Thus, 5, 10, 20, 40 is an example of geometric sequence. Common ratio, denoted by R, is a constant multiplied to each term of the geometric sequence to obtain the next term of the sequence. So from the previous example, 5, 10, 20, 40, the constant number that we use is 2. So in this example, the common ratio is equal to 2. Now, how to determine the ratio of a geometric sequence? So to find the common ratio, we simply divide any term of a geometric sequence by its preceding term. So for example, what is the common ratio of 7, 28, 112, 448, and 792? So to get R, we can choose any term of this geometric sequence. Say for example, 112 divided by its preceding term. The preceding term or the number before 112 is 28. So we divide this by 28 to get the common ratio. So 112 divided by 28, this is equal to 4. Or you can also choose, say for example, 28 divided by its preceding term, which is 7. So 28 divided by 7 is equal to 4. So the common ratio is 4. For example number 2, what is the common ratio of 400, 125, and so on and so forth? Again, to get the common ratio, we can choose any term divided by its preceding term. So say for example, we have here 100. So 100 divided by its preceding term or the number before 100, that is 400. So this is 100 over 400. This is equal to 0.25. Or in decimal, this is equal to 1/4. You can also choose 25 to get R. 25 divided by its preceding term, which is 100. So over 100, this is equal to 1/4 or 0.25. They are just the same. Let us try to find the common ratio of the second number to the first number by matching column A to column B. So, to find the common ratio, that is succeeding term divided by the preceding term. So, for number 1, the succeeding term is 5 and its preceding term is 2. So, for number 1, R is equal to 5 over 2. And that is letter C. So, we can match number 1 to letter C. For number 2, the common ratio is equal to succeeding term, which is 9 divided by 3. 9 divided by 3 is equal to negative 3. So for number 2, we can match this to letter E. For number 3, we have negative 5 and negative 10. The succeeding term is negative 10, preceding term is negative 5. Negative 10 divided by negative 5 is equal to 2. And that is letter B. For number 4, r is equal to negative 1/2 divided by 1. Negative 1/2 divided by 1 is equal to negative 1/2. Number 4, the ratio is in letter A. For number 5, the common ratio is equal to succeeding term, which is a sub a raised to 3 divided by a raised to 2. This is equal to, when dividing a variable, we simply subtract the exponent and copy the base. So the base is a, 3 minus 2 is equal to 1. So a raised to 1, or simply a. It's letter D. It should be a small letter. Now we have here a word problem related to geometric sequence. Ball bouncing is one of the situations that shows geometric sequence. Each time it hits the ground, it bounces to 80% of its previous height. What will be the first 5 terms created by a ball that was dropped from the height of 100 inches? So the initial height is 100 inches, or your first term is 100. To get the second height, or your second term, we simply multiply 100 by 0.8 or 0.80, or this is the 80%, since it was said that each time the ball hits the ground, it bounces to 80% of its previous height. To get the 80% of the previous height, or 100, we simply multiply 100 by 0.80, and this is equal to 80. To get the third height, or the third term, we multiply again, or we get again the 80% of the previous height. So 80 times 0.80, this is equal to 64. And the next term is, we multiply again the previous height, which is 64, by 0.80, and that is equal to 51.2. And your fifth term is your previous height times 0.80, and that is equal to 40.96. Now, the first 5 terms created by a ball that was dropped from the height of 100 inches is 100, 80, 64, 51.2, and 40.96. Now, let us try to find a geometric sequence given the first term and its common ratio. So, example number 1, give the first 5 terms of the geometric sequence whose first term is 7 and whose common ratio is -3. So, we are going to find the first 5 terms, 1, 2, 3, 4, 5. So, your a sub 1, or the first term, is equal to 7, and the common ratio is -3. Now, to get the a sub 2, or the second term, multiply your first term by the common ratio. So, that is equal to -21. To get your third term, second term times the common ratio, and this is equal to 63. Then, to get the fourth term, previous term, which is 63, times the common ratio, that is equal to -189. And the fifth term is equal to your fourth term, 189 or negative 189 times negative 3 is equal to 567. So the first 5 terms of the geometric sequence is 7, negative 21, 63, negative 189, and 567. This is the first 5 terms of the geometric sequence whose first term is 7 and whose common ratio is negative 3. Now, determine the next 2 terms of the geometric sequence 16, 24, 36, and so on and so forth. So, we have to get first what is the common ratio of the given geometric sequence. So, we can choose any term. So, say for example, 24 divided by its preceding term, 16. So, 24 divided by 16 is 3 halves. Or, you can choose 36 divided by its preceding term, which is 24. This is equal to 3 halves. How do we get 3 halves? We simply get the lowest term of 24 and 16. We can divide this by 8 to get 3 halves. Pareho nito, we can divide this by 12, both the numerator and the denominator, to get the lowest term, which is 3 halves. So, the common ratio is 3 halves. Now, what will be the next 2 terms? So, we have here 16, 24, 36, and the next 2 terms. So, to get the next term, we simply multiply the preceding term, which is 36, by the common ratio, 3 halves. This is equal to, so we can cancel 36 and 2. We can divide both by 2, so this will become 1, and 36 will become 18. We divide both by 2. So, ang matitira na lang is 18 times 3, and that is 54. So, this is 54. To get the next term, preceding term, which is 54, multiplied by the common ratio, 3 halves. This is equal to, we can cancel 54 and 2 by dividing each by 2. So, this will become 1. 54 divided by 2 is equal to 27. So, 27 na lang dito and 3 na lang sa other side. So, 27 times 3, this is equal to 81. So, the next term is 81. So, now the geometric sequence is 16, 24, 36, 54, 81, and so on and so forth. For the third example, you are going to supply the missing terms of the sequence. So, we have here 5 terms, and the given are the second term and the third term. So, we can divide the third term by the second term to get the common ratio. So, we'll just simply divide the numerical coefficients 50 and 10. So, 50 divided by 10 is equal to 5. And dividing the variable, we simply copy the base and subtract the exponent. So, 3 minus 2 is 1. 5a raised to 1, or simply 5a. So, the common ratio is 5a. Now, what will be the next term? So, we have here a sub 1, unknown pa siya. A sub 2 is equal to 10a squared. A sub 3 is equal to 50a cubed. A sub 4 is, we simply multiply the preceding term by the common ratio, 5a. So, this is equal to 50 times 5 is equal to 250. A cubed times a is a raised to 4. Now, when multiplying variable, we copy the base, the same base, and we add the exponent. So, we have here 3 and 1. 3 plus 1 is 4. So, 5a cubed times 5a is equal to 250a raised to 4. For the fifth term, the preceding term is 250a raised to 4 times the common ratio 5a. So 250 times 5 is equal to 1,250. A sub 4 times a is equal to a sub 5. We copy the base, we add the exponents. 4 plus 1 is equal to 5. So the fifth term is 1,250a raised to 5. Now, to get the first term, we do the reverse process. So, since nag-multiply tayo dito sa 10a squared ng 5a, we are going to divide this by 5a to get the first term. Kasi papunta tayo sa left. So, 10 divided by 5 is 2. A squared divided by a is a. So, the first term is 2a. 2a, 10a squared, 50a cubed, 250a to the fourth, and 1,250a to the fifth. Now, let us determine the common ratio and solve the next two terms of the following geometric sequence. So, for number 1, we have here the geometric sequence 80, 20, 5, and so on and so forth. So, to get the common ratio, we can choose any term. So, I'll choose 5. Divided by its preceding term, the preceding term is 20. So, the common ratio is 5 to 20, and we can still get the lowest term of 5 over 20 by dividing the numerator and the denominator by 5. So, this will become 1. This will become 4. This is the lowest term. So, the common ratio is 1/4. Or, in decimal, this is 0.25. Now, what will be the next two terms? So, we have here 5. That is a sub 3. So, to get the fourth term, we multiply the preceding term 5 times 1/4. 5 times 1/4, numerator times numerator, we have here imaginary 1 as the denominator of 5. 5 times 1 is 5. 4 times 1 is 4. So, the fourth term is 5/4. The fifth term is preceding term, which is 5/4 times 1/4. This is equal to numerator times numerator, that is 5 times 1. Denominator times denominator, that is 4 times 4 or 16. So, the fifth term is 5/16. Now, the terms after 5, 80, 25, are 5/4 and 5/16. This is now the geometric sequence for number 1. For number 2, we are going to find the common ratio. You can choose any terms. Okay, so I'll choose 20 divided by its preceding term, which is 30. Get the lowest term, 20 divided by 30. We can divide both by 10. So, that is 2 over 3. So, the common ratio is 2/3. So, we have here 3 terms, 45, 30, 20. To get the fourth term, the preceding term is 20 times the common ratio, 2/3. So, 20 times 2/3 is equal to, we have here imaginary 1. So, 20 times 2 is equal to 40 divided by 1 times 3 is 3. So, 40 over 3. Wala nang lowest term. 40 over 3 na. So, the next term, the fifth term, is the preceding term times 2 third is equal to numerator times numerator. This is equal to 80. 40 times 2 is 80. Denominator times denominator. 3 times 3 is equal to 9. So, this is now the fifth term. So, the first 5 terms is 45, 30, 20, 40 over 3, and 80 over 9. This is now the geometric sequence for number 2. For number 3, the common ratio is equal to, so let us choose 64 x raised to 7 divided by its preceding term, which is 16 x raised to 4. So, we divide 64 by 16. 64 divided by 16, that is equal to 4. X raised to 7 divided by x raised to 4. Copy the base, which is x. Then subtract the exponents. 7 minus 4, that is 3. So, the common ratio is 4x cubed. So, we have here given 3 terms. To get the next term or the fourth term, the preceding term 64x raised to 7, multiply this by the common ratio 4x cubed. So, 64x raised to 7 times 4x cubed. We multiply the numerical coefficient 64 and 4. 64 times 4 is 256. Then, we multiply x raised to 7 by x raised to 3. We copy the base, and we add the exponents. 7 plus 3, that is 10. So, the fourth term is 256 x raised to 10. And the next term, this is equal to the preceding term, 256 x raised to 10 times the common ratio 4x cubed. So, this is equal to, we multiply the numerical coefficients 256 and 4. So, 256 times 4, that is 1024. X raised to 10 times x raised to 3. Copy the base, add the exponents. 10 plus 3, 13. So, the geometric sequence will become 4x, 16x to the 4th, 64x raised to 7, 256x raised to 10, and 1024x raised to 13.